everyone. This is software engineering class. This is next session of the object-oriented software. In the last class, I have talked about the object-oriented software and that what is object and the advantages and how to coding. So now, as a second lecture, I am as a second lecture, I'm introducing a design method for object-oriented software. To this end, I'm going to introduce uh, a modeling language that is called Unified Modeling Language, that is UML. And UML stands for Unified Modeling Language, and it is a standardized visual modeling language used for specifying, visualizing, constructing, and documenting the software system, as well as for business modeling and other non-software systems. So UML provides a standardized and widely accepted notation for modeling system. It offers a common language that allows developer, designer, stakeholder to communicate and understand the system design and requirement effectively. The standardization of UML ensures consistency and promotes clarity in system document. So UML provides a visual and visual representation of system model and making them easier to understand and communicate. They offer a way to visualize the complex system, their component relationship and behavior, helping all the stakeholders to grasp the system structure and functionality more intuitively. UML diagram facilitate effectively communication among team member, client, and other stakeholders, promoting a shared understanding of the system. So UML supported the analysis and design phases of software development by creating UML diagram. Developer can analyze system requirements, identify classes, component, relationship, and design the system architecture. UML helps in identifying potential design flaws, making informed design decisions, and capturing design decisions for future reference. So, UML provides a set of notation and guidelines to visualize object-oriented software system under development. And it visualizes documented system software system and can that helps to analyzing software development. Okay. Also, because this UML unified modeling language is used for visualizing software system, it can generate software code using some tools. And UML can broadly categorized into following two main types. One is structural design diagram, and the other one is behavior diagram. Structural diagram describes static aspect of the system, and behavior diagram captures the dynamic aspect, that is changing, moving part of the system. First, I'm going to introduce the structural diagram, and structural diagram has several categories. There is class diagram, object diagram, component diagram, and deployment diagram. Okay, and class diagram describes classes, interfaces, and their association and collaboration, and that describe object-oriented view of a system. Okay, an object diagram describes instances of class diagram. So class diagram describes just a view of a system, concept of a system, that is what kind of classes in a system and what kind of class communicate to each other, and what shape of each classes in a system. The class diagram describes such thing, and object diagram describes instances of each classes. Okay, and there's another structural diagram that is called the component diagram and represents a set of components and their relationship. And component diagram illustrates the organization and dependency between software components in a system. Component is a set of classes or one independent system. Okay, so there is class and object. That is basic unit in object system, and component is a collection of classes. You can think like that. Okay, and there's another structural diagram that is called the deployment diagram, and that is also the set of node relationship and that visualizes deployment of view of the system. And here is basic, the detail of class diagram. But actually, class diagram has more detailed thing. But for these classes, I'm just going to introduce basic stuff about class diagram. Okay, class diagram, as I told you in this class, describe classes, interface. Okay, so class diagram describe classes, their relationship, and classes are represented with boxes like this. Okay, there's boxes here, boxes. Contain three components. One is name of class. This is name of class. Attribute, in other words, variable here, and operation here. Okay, so in class diagram, they don't contain any source code, any logic, any routine. Just it contains the name of class, name of variable, name of method. And in previous class, I told that one class includes name and attribute and behavior, like method. Okay, so this class diagram includes such information about name of variable and name of method. Okay, so by using class diagram, users or programmer or all the stakeholders understand the class's content. Okay, even though this class diagram does not provide any algorithm or data structure thing or just any routine, but this class diagram providing just a name and that gives a brief view or some descriptive information about class. Okay, so by using class diagram, user can check what kind of classes is in the on one system, and user can see what kind of how those classes interact with each other. Okay, so this guy has a name of class, name. Okay, so in class diagram has one box with three components and the class name, variable name, and method name. Okay, that should be included in these classes. And here you can see a plus and colon and data type and parameters. Okay, so when you define the variable, you have to define type like a string, text, integer. So it should be described in class diagram. Okay. Also, when you providing some kind of method, so it must have parameters and return type, and they should be presented like here. Okay. So in class diagram, okay, class diagram, class name, okay, this is class name, okay, and here, this is the method name, and here, yeah, variable name, okay. Okay, here. and it must have type of variable. Okay. Okay, type of variable. In here, type of variable. Okay, and it must have method parameter. Okay. This is a method name here. Method parameter. Okay, so okay, so here, like here, okay. And also in class diagram, they may have some kind of relationship between each classes. So that is the named one type of relationship is easier relationship. The other one is has a relationship. Okay, easier relationship is kind of inheritance. I give some example, for example, animal, dog. In this case, you can say like that. Animal is a dog. Okay, so in this case, inheritance animal, dog is animal. Okay, this is easier relationship. You see that this is a easier relationship. Okay. Okay, so is animal. Okay, there is easier relationship. As you can see here, dog is a special thing, and animal is more general thing. Okay, so when you mention two specialty and general thing together, then you can describe like using the easier relationship. Like a dog is an animal, cat is an animal, or like a for the table is furniture, chair is a furniture. That is an easier relationship. Typically, in easier relationship, subject has more special thing and object will be more general thing. Okay, so easier relation. Also, class has two classes may have header relationship. Okay, header relation means uh, if one method, like here, include another type of classes as an instance, then it means header relationship, okay? And in header relationship, there are two type of relationship. One is composite, the other one is aggregate. Composite means two classes, and if one class is destroyed or no longer used, the other class is automatically destroyed. Then in this case, a composite relationship and aggregate relationship is one class. Even when one class is destroyed, the another one can survive. Then in this case, we can say the aggregate relationship. So here is the example. We have four classes: movie, comment, user, action movie. Okay, look at this here. Okay, look at this. Action movie is a movie. Okay, this is a relation. Okay, is a relation. Also, action movie is a special type of movie. So that is inheritance. Okay, so because there is inheritance, we use this kind of arrow for this between two methods, two classes. One movie, action movie here. There's arrow with this is empty head. Okay, empty head arrow. Okay, so this is inheritance. Okay. Okay, so in this case, as I told you as I said in last classes, in inheritance relationship, action movie has all these variable and method together. This is the unique thing. This is a common thing. Okay, so as you can see in this picture, action movie has two variables, rating, budget, and generating the budget. But this is a inheritance relationship. So in this case, this movie class, action movie class, and action movie class has more variable like a rating, budget, as well as name and information. Also, action movie has method calculating a budget as well as add name. Okay, this is inheritance relationship. And there is another type of relation like here. So you can see like this. Movie has comment. Okay, has a relationship. Okay. Also, movie. No. User movie. It's just a little weird, but like thing is like this. Movie has a movies. Movie list. Each user and all the user has a movie list. Okay, so this is also has a relationship. Okay, so has a relationship. So in this case, look at this. In this case, when a movie is gone, that means when movie is deleted, then their comment will be deleted. Okay, when a movie deleted, then the comment movie will be deleted. Okay, so that means composite relationship. Okay, also in this case, when a user deleted, but movie will not be deleted. Okay, because the movie the user may have include the movie. Okay, so in this case it's aggregate. Okay, so here is the one. Okay, that is basic example here. So there is relation, and in class diagram you need to define more relationship, but this is a basic part of UML, so an introductory part. So just I'm going to introduce very basic thing about the class diagram. Just in class diagram, there's a rectangle, includes three components: name, variable name, and method name, and each name has indicate type of variable or type of return type with some parameters. Okay, so return type and parameter here. Also in this case you have to identify some kind of relationship between classes, and if two classes has kind of easier relationship, or it has some kind of inheritance relationship. In this case, you mark some relation like this, like an empty head arrow, okay? Also, this movie comment user, they are not either relationship, okay, but they are kind of had a relationship. That means each movie has a comment, their own comment, and each user has some kind of movie list, okay. In this case, okay, you can see if movie's gone, comment should be gone, okay. So in this case, you have to note like a composite relationship, component relation, and in this case aggregate relation, okay. Also you can claim that like the relation here, the one movie several comment, okay, one user several movies, okay. Actually one user can see several movies, okay. Maybe one user never seen a movie, another user have seen hundreds of movies, okay. This shows the relationship, okay? So that is basic part of class diagram, okay? So class diagram is used for analysis and design of static view of an application. And it is describes responsibility of system and map with object-oriented language and widely used at the time of construction. That means when you start coding with object-oriented language, then you start to build classes, okay? These classes definitely have some variable and some method, and when you're constructing your system, then this class diagram will map to your system, okay? So maybe while you're constructing your own system, construct coding, then maybe you can build this class diagram at the same time, but I recommend before you start coding, first build this kind of thing first, okay? Just this class diagram gives some basic concept or basic understanding of total system, okay? So you build this kind of system, this kind of UML diagram, class diagram, then once you finish it, to create this kind of class diagram, then you can start your class first. And you already define the method and variable name, then it will just make faster coding, okay? Also, before you start coding, you can review with your team member about using the class diagram. Then you can review the class, so well defined, correctly defined, and if that is enough, or is there anything needed more, or maybe you by reviewing this picture you can decide by adding more classes or more method, more variables, okay. So once you create this kind of class diagram, then it's very not that hard to start coding because you have already classes and method name, and what you have to do is just to fill each method with your own logic, okay. So, and second stat diagram is object diagram, okay. It describes class instances using during software execution, okay. Class diagram represents an abstract model of classes and their relationship. Instance diagram captures static view of system at a particular moment, okay. So here is example here. You have user class, movie class, comment class, okay. While learning, maybe you arbitrarily by thinking, you learn the system, and at some specific time, maybe you have a class called user, instance of user class, instance of a movie class. One is Star Wars episode 1, the other one is episode 2, and they may have several comments, okay. So by using this kind of object diagram, in class diagram, look at this class diagram. Class diagram include class name and variable and method. That is a source code level information, okay? And this guy shows runtime level information. And by watching class diagram and object diagram, maybe you can understand how the system is defined, how system is learning, and how each class is working and run together. Okay, you can see here user name is Kim. User has two movie. One is Star Wars, the other one is Star Wars Episode 2, and Star Wars Episode 1 has two command. Okay, this guy has three command, and as you can see here, one user has two movie, so it's a 1 to n relation, and it must be has a relationship. Okay, and each movie has several comments here. So if movie is gone, then the comment should be gone. But if user is gone, but no problem, because movie will be linked with another user, so you don't have to remove the movie object, movie instance or movie object. Okay, so this object diagram describe some kind of snapshot. Okay, during execution. Okay, you are learning here at some moment. Okay, maybe you may have several classes or instances of classes, and each instance will have several some values inside of each this instance. Okay, so this shows this kind of thing, and by using both class diagram and object diagram, maybe all the stakeholder, including engineers, programmer, can understand the whole system easily. Okay, so this is object diagram. Also, the another diagram is a deployment diagram. This deployment diagram describes a hardware component where software component is deployed. And it visualizes hardware topology system like here. So here is the user, here is PC, it's a modem, it's a LAN card something, internet, there's server, this is a proxy server, and there's some three type of server, and this is a caching server, means this could be web server, and this could be application server. So this is basic architecture of your system. So this deployment diagram describe whole hardware component with the software component. So more easier to understand because it describes hardware things. So typical user or just customer get some intuition about the final system. Okay, so this deployment diagram can be used for presenting the customer uh, about your software system with some hardware. Okay, so there is deployment diagram is a very popular one. Okay, so your customer may not have interest in this kind of class or object diagram, but customer will definitely have interest in this kind of deployment diagram, because deployment diagram shows some kind of hardware component and users, so that gives further understanding of the system to the customer. Okay, so there is another diagram that is called behavioral diagram. Okay, it has several types of behavior diagram, like a use case diagram, sequence, collaboration, state, and activity diagram. Okay, in use case diagram represent the use case of system, and sequence diagram describes sequence of message flow from one object to another, and it visualizes the sequence of calls in a system to perform a specific functionality. And collaboration diagram describes interaction among classes, objects with structural aspect of a system. State diagram describes event-driven system. Okay. Activity diagram describes a flow of control of a system. So just this is a use case diagram, and I give some explanation of use case diagram in the class before, when I give you assignment. Okay, so it describes tasks. Okay, and shows relationship between user and the system here. Okay, So in this case, system has several functionality like a login, start server or stop server, adding comment, movie, action movie, change page layout. There's several functionality, and some functionality is associated with the user, and another some functionality is associated with some administrator. Okay. Also, this for login, user have to provide email address. Okay. uh, and to add comment, you just have to type the comment, okay, in some specific input box, okay. And to add a movie means user if you just want to some kind of report or some kind of essay or document or something to say for movie, then user adding some movie, okay, uh, adding some comment for the movie. Okay, so add a movie to add a movie, then you have to type movie name and their information. Okay, so also there is add movie, action movie, because of movie and action movie is kind of easier relationship. Okay, action movie is a movie. Okay, so easier relationship, and they have inheritance. So you have to add extend because there is some inheritance relation. Okay, and for admin side, okay, admins have to start and stop server, and admin have to change the page layout or page content. Okay, so this is a use case diagram. So that describe functionality, and the functionality is associated with some kind of user, okay, actor. That is called, we say this kind of thing as a actor. Okay, actor, okay, here's actor, this is functionalities. Okay, okay, so here is one, and this is input, action, maybe action from actors. Okay, actors here. Okay, okay, so that describes user tasks. Okay, so this is the user case diagram, and this gives very brief functionality, brief description of a system. Okay, it provides some kind of functionality, and with one picture, it is a basic functionality of a system. So user or stakeholder see this user case diagram and watch them, and it summarize the total system functionality. Okay, and working mechanism. Okay, so to this end, you have to describe some functionality inside of a circle, and you have to define actors associated with such a functionality, and the association is linked like here, okay, linked like here. Okay, also you can add some kind of tags for each link, like an email address, input comment, something like that. Okay, so this is a use case diagram, and it gives brief uh, uh, brief description for system. Okay, and here is sequence diagram. Okay, sequence diagram shows how objects operate with one another in what order. Okay, so sequence means kind of order of step. Okay, to order of action. Okay, so it describes the sequence of um, um, actions for a functionality. Okay, and in this case, action is because it's a method, it's a method call, okay, because it is an object software, okay, like this, okay. So let me give you an example here. SQL is an order management system. Okay, so in this case, because this is object-oriented language, object-oriented software, so it has 4 classes. Okay, sys, customer, order, special, order, and normal order class. Okay. Okay, 4 classes here, and customer, order, special order, normal order. And to run the order management system, there is some method call for each instance. Okay, so here, initially, the routine will be initially the customer class calls order send of the method. Okay, and this method will invoke another method call like a confirm method from special order. Okay, and sometimes special order class calls its own method like dispatch, and because method call, it must have return here. Okay, we must have return. So this sequence diagram shows a sequence of method call. Okay, sequence of method call in one functionality. Okay, so here, and one more thing I have to say is there is a dashed line and there is a boxes, narrow boxes here, and this narrow box is called lifetime. Okay, okay, this is a lifetime of instance here. Okay, so this means this orders instance, customer instance, instantiated when the system start. Okay, when this call, okay, there's some call from outside about to the customer class. Okay, when this call is invoked from the customer side, the order instance should be activated together. Okay, here this guy, because this guy started here, and special order instance will be invoked when right before the order instance called invoke confirm instance. Okay, only when this is invoked. Okay, so this is a lifetime. Okay, so there's more detailed thing is inside of sequence diagram, but as an introductory course, I'm going to introduce very basic thing. Okay, so sequence diagram describe a sequence of operation, sequence of method call to run one functionality. Okay, in one functionality may need several classes, and each class will interact together to run a functionality. Okay, typically. So in this case, customer class invoke order classes send over method. Okay, or order class at the next time, order class will invoke confirm method of special order class. Okay, and special order class invoke this method, but it doesn't include any other classes, but it will invoke another method called dispatch, and all the method call have some kind of return routine. Okay, so if return routine have some kind of message, then you have to use the solid line with some message return thing. Okay, but if the method doesn't have any return message, then just you can use the dashed line here. Okay, so this is a code sample of the above sequence diagram here. In customer, okay, there's an initialization, and you have to initialize new order class. Okay, so here is the order. Okay, this and order is given as a parameter. So my order is instantiated. Okay, so here customer, and maybe by some time by calling something, it customer class invoke one method from my order, and my order invoke send order may have in this case this guy have a new order here. Okay, and it calls new method confirm. Okay, let me check. I'm not sure that it must have Python method must have a new method. Let me see. Okay, Python. Okay, Python doesn't need a new method. Okay, that is fine. Okay, so here also in special order there's its own message dispatch and confirm here. Okay, so here let's go again here. So this sequence diagram is talking about the call, send order, confirm, dispatch. Okay, and it has return. Okay, send order, confirm, dispatch. Okay, so in this case, send order, confirm, and dispatch. Okay, so that is to learn some functionality about the send order, you have to in object-oriented system they have some multiple method calls to learn one functionality like here, and this sequence diagram describe this kind of stuff. So if you create a sequence diagram before you start coding, then maybe you can make, you have to in this case this diagram helps to design this kind of coding. Okay, so also if you have a sequence diagram, correct sequence diagram, then maybe some other people, not you, by watching this sequence diagram they can understand the source code. Okay, actually watching source code is very hard thing and very boring thing. Okay, that's sleepy and not easy to see, but if you have a sequence diagram like this, then that helps the understanding the source code. Okay, also there is another one is state diagram. State models dynamic aspect of a system and typically used to model reactive system, in other words event-driven system. Okay, and state is a condition in which object exists and the condition changes when some event is triggered. Here is the example, state example here. There's ice state, water, it has let me see. Our system has 3 states. Okay, ice, water, vapor. Okay, so ice state is changed to water state by action heat. Okay, likewise water state changed to vapor state by action heat. Okay, and maybe water state changed to ice by action cool. Okay, that is state change and state diagram Okay, so here is state diagram. But in this diagram doesn't have any start and final state, but typically state diagram has a state and final state. And here is another example here. Look at here. This is gas station pump system. Okay, so initially it is start position here. Okay, and maybe by turning pump on action. Okay, this is action. Action. By turn pump on action, it goes to start screen state here. Okay, and turn pump off action, it will be final state. Okay, it will change final, and once it reaches final state, it's done. Okay, you have to go to this state and you have to restart the system. Okay, also in start screen, and if someone is doing insert card action, then its state is moved to here, okay? Card validation state, and at the card validation state and doing something, okay? And maybe in card validation state, it is validating card, okay? So finally, validation failed, then it moves to validation fail state, and after 10 seconds, then it goes to the initial state, like a start screen here. Or if card is validated, and the state is moved from the card validation state to a pump ready state, okay? And if pump ready state, no action for 1 minute, then it goes to here, okay? So this is a state diagram, okay? So each state has some kind of state, okay? State is a condition and some event triggered, okay? Also, the state, the state within state, I'm sorry, state can include their own actions, okay? Actions, okay? So in this case, card validation state, there's no mention, but this state may include some action like validating card, okay? So, and after validating card, maybe it has some kind of result, and based on result, state can be moved from card validation state to validation phase state or pump ready state here, okay? That is some kind of card station pump station here. And once you have this kind of state diagram, then maybe you can start coding like this, okay? So state is initial, and while state is not final, this is final, okay? And if state is initial, okay, here is the initial, okay? Then check pump on and state move to state, okay? This is, oh, sorry. This guy checks actions, okay? Okay. So state will be changed, and there's no action, then state is the same state, okay? Same state, okay? Else if state is start screen, okay? If current state is a start screen and check insert card, and maybe check card is inserted, then state card validation, okay? Card validation state failed or validated, then maybe state will be changed here, okay? So this is how you start coding using state diagrams. So in event-driven system, before you start coding for the event-driven system, if you have this kind of diagram, then you can start coding like this, and very easy, okay? So one thing clear is, if you start coding first like this, and then maybe you may have some confusion, okay? You may have several error, logic error, but before you start coding, if you have this kind of diagram first, then by checking some transition, state transition, by checking action, then you can find some missing thing, or you can find the flow errors in this diagram. Then you can validate more easily for your system. And once you review and then find this state diagram is correct, then you can start coding like this, and then we make it shorten your coding time. Okay, so this is how to design the state diagram, how to use state diagram here. Okay, so in like a sequence diagram here. Okay, once you have a sequence diagram, then you can start coding like this. Okay, so simply speaking, if you have class diagram, then you can start coding with some class and method. And next step is you have to fill the code, and then you can design your own logic. And if you have a sequence diagram like this, then you may have more accurate sequence of the method calls. And so by checking sequence diagram, maybe there's a high chance of changing or modify existing class diagram and sequence diagram together. Okay, so building sequence diagram, building class diagram, you should have to learn it together. Okay, so also especially when you need to design the state event-driven system, then it's good it's good to build state diagram like this. Okay, once you have a state diagram like this, okay, then event-driven system can be coded using if-else statement like this. Okay, but in this case, a very long code, so it would make confusion. But if you have this kind of diagram first, then it can be validated easily. Okay, so shared and validate easily, so it will make more corrected source code, and more correct source code, and it gives shortened development time. Okay. And there is another UML code like called activity diagram, and it uses a flowchart constant of activity performed by the system. So here is the one. Okay, this is a starting point and this is the ending point, and this guy is action activity, and that is condition. Okay, and the result here, and this is the condition check. Okay, so this gives some kind of routine needed for executing some functionality, and this is called, in other words, flowchart. Okay, so maybe at your initial point of development, it's better to build this system rather than class or sequence diagram. But it's okay. First, start this diagram first. Then, once you have this first, then next time so using this diagram, you can build class and sequence diagram together. Okay, sequence and class diagram is more detailed level of source description for system, and this is a more higher level of description of a system. So in activity diagram, you describe some detailed action with some kind of conditional execution here, and there's some kind of this is a conditional executor, and condition should be checked like this way. Okay, and this is the result. Okay, so yes, no, yes, something. So this is order system. So maybe it should be built first initially, and once you have this guy, and you can start coding and directly, or maybe you can design sequence diagram from this activity diagram and class diagram from activity diagram. Okay, then you can start a more detailed design of system you from the activity diagram. Okay, and so this is basic stuff about the UML. Okay, Unified Modeling Language. Okay, so so if your system has many functionality, then and complex system, then I recommend from start to use case diagram and activity diagram. And once you have done for use case and activity diagram, then it's better to design as a next step, design class diagram and sequence diagram. And in class diagram, you have to decide the function name and the class name and method and variable. And sequence diagram describes sequence of function code. And together, you can build basic structure of system software system architecture. Okay, and then okay, now I have explained about how to design. Okay, but maybe to design you have some kind of information what kind of thing you design, and the information should be from the requirement. Okay, so you have a requirement, and the system design, like using UML, is the next step of defining requirement. Okay, you must have requirement first, and then you start designing using UML. Okay, so then how to make UML design from requirement? And typically, you're using the sentence structure. Okay, you need to use the sentence structure. First, you identify nouns and verb, and nouns will be object or object variable. Okay, and verb will be method. Okay, so the typical structure. So if you find some noun, some important noun, then you say that, okay, this is one class. Okay, so you've in a required document, if you find a noun, okay, then those nouns can be classy. And if the class is too small, or if you feel too many classes, then some noun can be object attribute. Okay, and the behavioral part, if you find it from one sentence, some verb, then this will be behavior. Okay, so very easy starting point about this kind of stuff. Okay, so like a scenario or requirement document said A send B to C. Okay, then A, B, C, all of them can be object, and and C will be object and B will be attribute. In each up to you, each how to define it. There's no rule what is object, what is object attribute. Okay, but just each decision, each up to your decision. Okay, and send will be noun, verbs, so they will operate in A. Okay, so and A, B, C are in same scenario. They have some kind of relationship. Okay, so that is it. Okay, so from here you can build something like some class A, B, and C here. Okay, see here, and maybe A, B, C, and maybe method A send B to C. So in this case, A and C will be class, and B will be something like attribute. Okay, so in this case, like this, okay, C and class A here, and C here, class C here, the two type of class here, and it gives some message to B. Okay, B from document here. Okay, and A send B to C. That means A must have send operation B. Okay, so here A has, and B will be in here. Okay, B will be operation like whatever text or integer something. Okay, like this. That's it. That is how to make one classes. And C class only receive from message from A class. Okay, so so to this end, okay, it must have A class as a something. Okay, so it must have A class as attribute. Okay, A class as attribute. And then it must have some kind of tool like receive. Okay, 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 like this. Okay, so here is the one. Okay, so maybe this will be one structure, but there's no clear answer. It's up to you. But anyway, if you find the scenario here, maybe you must have three classes. And it's maybe you can think there are three classes A, B, C. But why designing A, B, C, but B sent something, so A send B to C, so maybe B will be kind of attribute or variable, and send will be method from A. Okay, because A class A will send B to C. Okay, so maybe you create one class design from the one document. Okay, so that is how to build classes from requirement. Okay, and this class, when you start coding, it's much better have some kind of UML language and visual description. Okay, it's much better to have visual description for the system. Okay, so once you have, maybe if you think it's very tough to design a system, then maybe your starting point will be kind of activity diagram and use case diagram. Okay, in use case diagram you have a major functionality, and this functionality you can describe, you can build some kind of activity diagram, and once you have activity diagram, then you can start from the activity, you can start build from this activity diagram to create class diagram and sequence diagram. Okay, today's class end here, and thanks so much. And next class will be design pattern, and that will be final thing. Okay, thank you.